Hello there. Welcome back to the stream. Okay, seems like I am live. Awesome, great. Hello, welcome back. How are you doing today? I hope you're doing great. Mibox, guten Tag, Mibox. Wie geht's? I'm still polishing my German, since seems like I have at least one German viewer. Good. Yeah, that is great. That is really good. Even though it's only Wednesday, which is not the best day of the week actually. Well, it's still better than Monday, if you ask me. Okay, doesn't matter if it's Monday, Wednesday, or Friday, we still have a lot of work to do. So just a quick recap from the last stream. We were working on these mouse encoders. They look like this. I have a whole bunch of them, starting from 11 millimeters all the way to 16. So we were designing some kind of a harness, and of course during the stream we actually didn't manage to finish, so I did it off stream. So this looks like this, more or less. Of course it's still not fully functional because somehow I missed that the screws will be sticking out here, and it kind of maybe doesn't really interfere that much, but it rubs my brain the wrong way. I mean, it looks like there is a tiny gap, so maybe it's not that bad. Yeah, but this is how it looks like. It's a very junky design, just to see how it works. I can walk you through this design just quickly, because there are a few things I would like to share. Okay, so I think it looks like this. Oh, actually, this is for the magnetic one, and what we need the one with the shaft, so it's gonna be this one. Okay, so what I changed the shaft because originally it was too thin. The whole shaft was this thin, so it was very easy to break. So I decided to make the base a little bit thicker, like this. And if you look at it, actually it sticks out beyond the bearing, but that's not an issue because we can have it over here. Okay, I have this harness, which one? Okay, so it looks more or less like this. Yeah, so this is our holder for, let me just quickly highlight. So this is our holder for the encoder, and I can also highlight the encoder. Okay, it needs to move a little. I've been shifting stuff up and down, and I forgot to move the encoder, but that's not an issue. We can move it very quickly. Yeah, so it looks more or less like this. And what I just showed you is basically the whole piece, like so. Of course, these are the screws. Now I can see that it interferes, but when I was printing it, somehow I didn't notice that, but it's fine. It seems like there is still a small gap, so that is cool. So I did that off stream. I managed to print. Then I also took a look at these magnetic encoders. So at this moment I have only this one. This is AS5600. And initially I thought that I won't be using it, then I wanted to use it, and then I realized that after reading the specs, it turned out that the I2C address on this thing is fixed. I can't change it, and therefore I can only have one on the I2C bus, and I need 3. So this kind of rules it out. There might be possibility to use something like maybe a multiplexer. Maybe this would work. I am not quite sure if I can switch I2C like that. If I just let's say I would have the clock bus common for all the devices, and then I would just switch. I would use multiplexer to just switch between those different devices. But actually, yeah, that would be also tricky because all of them, they won't be on the same multiplexer. I mean, on one half I would have like one multiplexer and 2 devices. On the other half I would have one multiplexer and 1 device. I would have to also kind of synchronize between those multiplexers. So this doesn't seem to be a good idea, but I managed to design this, which is it's a knob that can hold the magnet that comes with these, and I left these tiny gaps over here, so it's easier to remove the magnet later on, because initially I had the whole shaft fixed. I mean, the wall was full, so once you pushed in the magnet, you can't get it out. Don't ask me how I know. Yeah, so that's another thing that I managed to design. Of course, I am sticking to the bearing design because obviously I can't have it on just the shaft. If you look at the shaft over here, so if I just remove the bearing, and remove the knob as well, or maybe not, I will just remove the harness. So without any support, without any bearing over here, and maybe I can just yeah, so there has to be something that will hold everything in place. It won't hold on just this shaft, it's too thin. It would make more sense to have it horizontal. Then actually one shaft should be good, should hold it. Like on the other side, I could have like a tiny bearing or something like that. I think we'll explore this possibility today as well, because I would like to redesign this. I would like to have horizontal and vertical as well, just to explore how it's gonna look like. I was also thinking of making a mock-up for Chordie. So we have this kind of like a prototype of Chordie from our previous streams. So this one allows for swapping the scroll encoder and the volume encoder. We used to use some screws just to attach it, and that was kind of cool, practical. Allowed me to quickly swap different ideas. So I was thinking maybe we can do this design today, start printing it, and then we can take a look how does it fit on the real keyboard. How does it feel to scroll? Does it make the whole board move around like it was the case with those bigger encoders? Yeah, and in the meantime, when it's printing, we can take a look at different variants. We can design a horizontal one. I also went ahead and I went on a shopping spree on AliExpress, and I bought those damn pop-ups from AliExpress. I think I should block it. Let's take a look at this one. Yeah, so I think I bought 5, 7 and 9, if I am not mistaken, at this point. And I think the 5mm ones will be definitely usable for horizontal version. Maybe for vertical as well, because since everything is kind of fixed on this bearing, and actually the whole weight sits on the bearing, and the bearing sits on top of the plate. Can I swap it like that? Yeah, I can take a look. Yeah, so basically this is what is kind of holding the bearing on top of everything. This is our shaft, and it goes to the encoder, which is over here. Yeah, so basically the whole weight sits on this. I also redesigned the trap for this for the bearing, because initially I just had a cylinder, and it was very difficult to find a good size that would make it easy to put the bearing on and remove it later on without using force, screwdriver, any kind of brute force. So in the end, I settled on this idea. Okay, you can see that it's something like this. So I just cut small pieces in between. So when I push the bearing in, the whole thing kind of contracts, and this space allows the plastic to kind of like contract. Then the bearing sits in and it's very tight. But when I want to remove it, it's very easy. I can just use a little bit more force and I can yank it out. So this is very good design in my opinion, and I think I will stick to it. Yeah, so today we will start with okay, there's one more thing before we start. If we go back to AliExpress and we search for magnetic encoders, there is one more, this one, MT6701. And what's so special about it? Well, the good thing is that it seems like it has some kind of a AB output. As you can see over here, there is a B and A. And if we take a look at the data sheet for this thing, do we have something in English? Let's take a look here. Yeah. So the cool thing about it is that, number one, there aren't many components needed to make it run. And another thing is that it has this ABZ output. Yeah, so if we look a little bit further, this is the part that I wanted, this thing. I am not quite sure at this moment, I might be wrong, but this looks more or less as a AB output from a normal encoder, so it would be like 0, 1, 1, 1, 1, 0, and I think this is like 0, 0. And if we do, this is for the counterclockwise, and for the clockwise, it's gonna be 1 and 0. So 0 and 1 is counterclockwise, and okay, and 1 and 0 is gonna be clockwise. So this is 1 and this is 0. So it looks more or less like a normal table for normal encoder. If we take a look, maybe EC11 Alps, there's some data sheet. Okay, let's check the Mauser. First one. And there's a data sheet. Yes, there's data sheet. And there should be a table like that over here somewhere as well. Dimensions, all this kind of stuff. Oh, there you go. Yeah. So as you can see, it's like if you look at it, it's very similar. 1 and 0, then we have 1 and 1, then we have 0 and 1, and so on. And if you take a look over here, it's very similar. Maybe I can... No, I don't have... it's gonna be difficult to put them all together. I think I need to split for the two halves. So anyway, it looks very similar, if it's not even the same. Yeah, so there is a small chance that we can get away with it, and we don't have to use any I2C reading over the bus. We can just connect everything as it was for the normal encoders, hopefully, and maybe we'll be able to read something. So I went ahead and I bought a bunch of these PCBs, if I remember correctly. I think I bought like 3. So hopefully they will arrive maybe this week, maybe next week, and we'll be able to test something. And in the meantime, we can play with this design and see if it's viable to have a normal encoder. I mean, the magnetic one is definitely better because there is no resistance from the encoder. So the only thing that is like resisting the movement is just the bearing, and end bearing is very smooth. So I would rather to have that, but at the same time, I don't really know how long this will be around. These PCBs, they might be gone in some time. And as I said in the beginning, I would rather have something universal. So maybe if this magnetic encoder really works, if it really have this AB output that I can use without any additional programming, without tweaking I2C. I mean, this one, from what I read, you can change the address, but you can only change this address to one other value. They don't really mention how many bits we can change in the address. I think they mentioned something over here. If I can find it. Yeah, there are 2 modes. There is UVW and ABZ. So you can program something as well. You can program how many pulses you want per rotation. But I hope we can get away with just default, whatever is default when it boots. Well, we're gonna find out, I guess, how it works out of the box. There is also a way to program it, so maybe we can just program it somehow, and then even if we disconnect power, all those settings will be retained because it's EEPROM memory, so I think it should be retained. So that wouldn't be that much difficult, actually. We can even make like a small Arduino program that would like allow to program it, and then just put it in the keyboard and use it. Yeah, so this is I2C interface part. And they do mention something about the address at some point. Yeah, okay, so here it is. So they say that the default slave ID is this, and it could be programmed to, yeah, so seems like we can only flip 1 bit over here. So we can change this a second digit, we can turn from 0 to 1. If we could change like 1 more bit, that would be helpful because we need 3. But this doesn't really help us at all. But still, if we can get away just by using these outputs, whether it's this one or ABZ, because it seems it's the same output, the same legs, or is it? Oh no, actually not. So there are different pins. So 6, 7, 8 is ABZ, and 9, 11, and 12 is WUV. Let's take a look how those pins look like. Oh, there's quite plenty. Okay, something like this. And the default configuration for it, if you want to use it, like the default schematic, yeah, so the reference circuit is basically nothing. There is a diode, Zener diode, 6 volts, but it's only recommended, so it's not a must. And we are interested only in this. This is SOP8. Yeah, SOP8 over here. Then how do I switch this off? Never mind. Yeah, so we need this. We won't be dealing with this. So I was even thinking that if it really works, it might be even possible to hand wire it, just like push it on the side of the, if we design like a horizontal encoder, we can just push it on the side somehow and just attach wires and route them somehow like through the back to the bottom or wherever you want it, because it looks like it doesn't really need anything. It only needs VCC, ground, and then we can just read those outputs. We just need to route those 3 outputs that we are interested in, and that would be actually very cool. So it's not that big. Yeah, so if it works, if we can make it work like that, that would be really cool. That would be great, actually. Okay, so the topic of today, we need to go back to this, and I think I would like to put it inside Chordie. Oh, not this one. Okay, so this is our design, and I would like to put it over here. So then we can start the print. And going back to AliExpress, we were looking at those mouse encoders from TTS. Not Kyle. TTC. Okay. And they had a really good data sheet. I mean, good, as good as it gets for AliExpress. Yeah, so it looks like most of the dimensions are fixed. So it looks like this part is fixed, and this part is also fixed where the legs are, and this part seems to be related to the height of the encoder. So this is 9mm encoders, and it says that this part is 9. So I was thinking maybe we can use that. And even before the encoders arrive from AliExpress, the K1s, maybe we can mock up a design for the 5mm ones, horizontal and vertical. Because looking at our project, this is the part that we can change. And I mean, this is the part that relates to the height of the whole encoder. So This one should be 11 millimeters. Yeah, 11.1. So basically, if we shrink it down to 5 millimeters, maybe this would be enough. Yeah, so but first things first, let's just yank this whole design from here, and let's just copy and paste it to our Chordie. Well, we can have a little bit of insight how it's gonna look like, because yeah, as we can see, this design already gives us a hint more or less how it's gonna look like. And I have to say that it's kind of okay, but you know, it's not really attached to anything. But the scroll is very soft. I don't think it will be moving the keyboard at all. Yeah, but we also have to figure out the height, because currently, if we have it like this, it's way taller than all the keys. But I was also thinking that since I was thinking maybe the rotation would be like this with the finger. So I think it has to be a little bit higher than this key. So when we rotate, we don't really hit this key. Now it's kind of too tall anyway, so we can go lower. I think it's like 5 millimeters or maybe even more. And we can make it like maybe 1 millimeter, 1.2. We see about that. Yeah, and also there's a lot of thickness that is not really needed here. So hopefully I will be able to copy and paste everything. Let's take a look. I wonder what will happen, because I think if I copy the whole body, it might do like a reference. Yep, it did. So as you can see, this is an outside body. So if I change something, it will change. There's a star over here. Yeah. So it's not really what I want, because I would rather have it separate in the old design. And this one is just like to test. So I think I have to copy one by one. I mean, I think I can unlink it. Okay, there's this option, use internal copy. Okay, so it seems like now it's internal. Well, I don't know why it copied everything. Okay, let's take a look. Let's say I will change something. Let's do 12, for example, and did the change here. Okay, seems like it's detached from the original file, so that's okay. Yeah, obviously, there's way too many elements over here. I think I can remove the magnetic ones, bearing. No, but the magnet won't be needed as well. Okay, let's just leave it like here. Okay, so first thing first, I would like to check the height of the keys. Okay, we have only those three. So I'm gonna activate this. I'm gonna copy one more key. And I think I have to move it both ways. Okay, maybe it will be easier if I just, because this one is 125. So I just need to make it smaller, make it 1905. But I think it will be easier. Okay, somehow it's not catching like the middle of the, I wonder why. Okay, not an issue. Maybe it has a problem with some other stuff. I'm not gonna hide it. I will just drop a plane over here. And maybe I should be able to move it. Yeah. So the plane is in the middle now. So from here I can do ruler to the plane. And I can do 1905 by 2, 953. And I can do the same thing from this side. So it's gonna be 1905 by 2. Okay, 953. Okay, looks more or less okay. We can get rid of this plane. And what is the height from here to here? From here to here we have 372. Okay. So let's anchor over here and let's do ruler. 373, was it? Or 2? I think it was 2. One more time. Yeah, 372 over here. Okay, so I think I did it correctly. Yeah, 372. Okay, so now if you look at it, we can grab it like this and okay, so how tall we want it? Let's say we want it to be 1.2. Is it gonna be enough? Maybe 2.4. Yeah, let's make it 2.4 just to be on the safe side. Okay, so now is the question of distance. How much distance from the key? So this part. So if you look at it, I think as long as it is higher than this key, the distance doesn't really matter that much. We can be quite close actually, because when we rotate, we shouldn't have like an issue. We won't be hitting anything. If we don't hit this key, we won't definitely hit this key, and the rotation will be like this. So yeah, I don't think the distance makes that much of a difference at this point. Well, definitely we're gonna find out. And most probably we have to reprint this part like 10 times, most probably off stream as usual. Everything is broken on this stream. Well, except for the stream, at least today. Yeah, anyway, so here we are. So maybe let's try to move it a little bit closer. So let's do like anchor over here and move it all the way to this wall and anchor here and move all the way to here. Okay, so for now I think we can hide the knob. The bearing is not that much really needed. Okay, so we have our mounting holes. One is over here and one is over here. And let's take a look at how high is the knob. Okay, I'm afraid we won't be able to use it. Yeah, it's gonna... Yep. So we won't be able to use this hole because, I mean, actually, yeah, we can use it because we can attach the knob later on. So that is actually fine. Okay, so let's hide the knob for now. And what do we have here? Maybe I should make it active. Well, now we have to decide if we want to make the shaft longer and put the encoder lower, or we can leave it as it is and just retain the same knob and everything. Because if we set up the top plate, okay, so the top plate kind of, okay, so it will kind of interfere. I think we should make it smaller a little. Okay. Well, first thing first, we have to raise the bottom because it's lower than the whole thing. Okay, so now it's all aligned. Let's extend it all the way to here and get rid of this part. So we need something to mount the screw. It should be good like this. If we combine that and we can make a hole now. Ah, too big. Okay, this is kind of odd. Can we fix this? It would be nice to get rid of this reach over here. But to do that, I think we have to split this part somehow. Or maybe I can just draw it like that. Yeah, so let's just project this part and make a line over here, like so. And then I should be able to pull it. Oh yeah, that is good actually. I hope this will be enough. How long is it? Okay, it's 10 millimeters, so it's like way more than we need. What is the height from here to here? Almost 12. Well, if we enable the bearing over here, so I was thinking of moving this outside. So maybe I can move these to the edges, maybe over here and one over here. Let's take a look. I think I closed the hole over here. It's not a problem. We can make a new one, or maybe we can't. Okay, and it removed the whole column. That's great. Doesn't matter. Let's hide bearing for now, and let's move this. Okay, so this is okay. So I think this is part of the base, this element. Yeah, so let's just copy and paste it. So we can use it over here. Okay. That went smooth. Okay, so we have the holes over here. So one screw goes here and the other one goes here. And if we show the bearing, then it shouldn't be touching the bearing at all anymore, which is great. Okay, let's take a look on this side. Do we need one more screw over here? Hey chat, do we need one more screw over here or we don't? Should I put one more mount over here? Like this? I'll just leave it, just leave this one hole over here. Just like we used to do with the previous design. So no, so just one is enough. Okay, so we skip it then. One hole is good. One is okay. Okay, great. As you command. Okay, so let's take a quick look. What have we done? And if it's even gonna work. So we have the top plate over here together with the yes, that is a possibility as well. But like now they don't really do any harm. So I think I will leave it like that. And also this way I don't really need this long screw, because like from the top I just need like a screw to here, and from the bottom I would need like a 12 millimeters. And I don't know if like if we take a look how was the so it's 1126. So I have either 10 millimeters or I think I have 12. So if we go with 12, then I would have to lift everything up, because otherwise the screw will be sticking out even more over here, like if we attach it from the bottom. So I think this approach is a little bit better. I can use shorter screws, and even if the head of the screw is a little bit sticking out, it's still way out of the reach of the bearing. Even with the original position, they were still kind of okay. If you take a look, so you see there is still a little bit of space. It's either hardly touching or there is tiny little gap. So it's not that bad, but now when they will be in the corners, I think that should be good. Move columns to other component. Well, I can't. I think I know what you mean. I think you want me to have the column attached to the top. Yeah, but I was thinking about it last time when I was doing it. But the issue is, if you look at this part, I won't be able to print it, because I can't print it on this side and I can't print it on this side. And it won't work like on the side, because then I would need some kind of a support over here. So maybe it will be easier if I show you in Bamboo Studio what's the issue. Like if I keep the columns like that, since you will be oh, you get it? Okay, yeah. Since you'll be a beginner 3D printer, so yeah, that's the struggle. Like you can't really have print like that. So yeah, I'm kind of bound to this design, which actually is not that bad. Should be fine. Okay, so let's do a quick check what we have done so far. So we have a mounting hole over here, and over here, and hopefully this will be enough to hold everything in place. We are at the same level, distance is 0. Okay, so this is our top plate. So that's our, I think I hit too much. Yeah, cool. Yeah, I can do that as well. Well, the issue is that with super glue, it doesn't really hold that well, PLA, as far as I know. Yeah, I know. Super glue, maybe not so much, but hot glue works. Hot glue is okay. Yeah, but we can do it like that. It should be good. I just need to check before I send it to the printer. I just want to be sure that everything is fine. Epoxy. Yeah, epoxy. Yeah, epoxy. True. I can't remember if I ever tried epoxy on any prints. I think I was trying to, yeah, I did use epoxy. I wanted to attach magnets to the 3D print, to PLA. I had something like a light LED strip holder for my 3D printer back when I had a different one. So it didn't really hold. The magnets came off. So maybe epoxy is also not that good for PLA. I might be wrong. Maybe I just mixed it wrongly. Yeah, but it didn't hold that at all. At some point, they just like they were stick to the frame, and I just detached the whole thing. Okay, so what do we have here? So we have the top. We have harness. Let's remove that. Okay, so this is our bottom. Hello there, SG District Homes. How are you doing today? Thanks for dropping by. Nice to see you. Glad that you found time to join us for this messed up CAD session where nothing really works. Okay, so that's the bottom. Yeah. You mentioned something about this last time, right? Like doing shit like this, left and right, rotating, screwing around with the print. Well, I think I know what you'll find most entertaining if I do something like this. Kaboom. Or maybe even better if I do something like this. If I make a plane, let's go like this. Let's actually... Yeah, but I have something better to show you. Let's do it like this. Oh. Yeah, but check this out. We can actually clip. Isn't it cool? Yeah, of course it's cool. Okay, enough messing around. Time to print this stuff. Okay, so what do we need? Oh, that's not what I wanted actually. Okay, where is the bottom plate? I think I lost it. Ah, okay, it's hiding over here. So I have to move it. Okay, so I think that's all for the base. Okay, let's export this. Let's call it mouse encoder. And this one is vertical. Is it okay? Mouse and vertical. And this is bottom. All right. And now we need to export the top. So the top and the bearing mount. So let's call it top. Okay, let's summon Bamboo Studio. Oh, no, you don't. No way. Yeah, so MeBox, now I mean, I know you know what was the issue, but just to show you, like, if it had columns underneath, I won't be able to print because they will be like sticking out somewhere. So I'll have to either like print it on the side or somehow, yeah, that's not feasible with this design. So it has to be like this. Okay, it seems to be okay. We don't have to mirror it? No, I don't think we do. If we take a look, this is left side. Yeah, that was left side, so yeah, no need to mirror anything. No connection problems. How cool is that? I like it when shit works. Okay, let's have a peek at the printer. If we go back. Okay, the print bed is clean. I didn't leave anything, so we can let it do its thing for a while. Okay, so while this one is printing, I think we can go back to the all the encoder designs, and maybe we can mock up, since we have 11 millimeters over here. So maybe we can mock up the 5 millimeters and try to figure out how to make it horizontal. So I will make a new component. Let's call it mouse encoder 5. And I will just copy stuff from here. Maybe let's make a group mouse encoders. Let's do it like this, mouse encoders, and it's got ME2 and ME11. Okay, so what I said, looking at the schematic over here, so I assume this this dimension is the only thing that is changing between all of them. Let's take a look. So we have 9 millimeters chose now. So let's go back and let's choose like 7. Oh, it didn't change. I was hoping it will update the schematic as well. Well, it didn't. Yeah, but I assume nothing else changes except for this. But if we take a look, maybe let's duplicate. Okay, so the 5 millimeters is kind of tiny, but I guess that should be fine, because when we look at it, I forgot to put the, so we have the shaft over here. Let's turn it like that. Okay, so this part we can hide for now. Where is it? I think it's this one. I think if I move it, it's gonna vanish. Okay, let's put this one here. Okay, now we are here, so okay, let's take a look. We don't need that over here. So let's make it 5. Let's make it 5.1. I leave some space. And this is the top. So it was 4, but on the drawing, if we take a look over here, I think it says it's 4.1. Yeah, 4.1. But we did the bottom 5.1, so okay, we can just forget about it. Let's move it over here. So basically, this is how it's supposed to look like. Let's do the shaft over here. Yeah, so this is kind of tiny. Okay, the harness, okay, it's too big a little. Yeah, so the whole harness will be even smaller, which is great. So I guess I will have to adapt also the harness for it, since we'll be using it anyway. So like, let's make a new one over here. Mouse encoder harness, let's do 5 millimeters. I still don't know if I'm typing harness correctly. Okay, for now. Okay, so the bass we can skip for now. Okay, so let's move the opening for the shaft, where the shaft actually will be. Okay, it doesn't want to move because why? Okay, it doesn't. So one more try. So these need to go all the way to here. Looks like it's a bit floating in the air. Okay, now it's correct. How's the printer doing? Okay, not bad. Halfway through. Okay, so this is our encoder, the gray thingy inside, and the thing that is supposed to hold it is the green one around. Okay, it looks kind of cool. I can't wait to receive those and finally test it live. See how they really fit. This might be the ultimate solution to our problem, to have like the low profile scroll and low profile volume, because I really didn't like the big ones, the EC11 ones, even though it's like only 15 millimeters, it's still too much for me. I can't really accept that. Yeah, these are way easier to rotate. That's another plus for them. Okay, so what I wanted to do, I wanted to make a small mockup. If you wanted to do it horizontal, which is, let's take a look, something like this. So there will be shaft over here, a very straight one like this, and we'll have some kind of a wheel. And then on this side, we'll have something, either another encoder, or maybe a bearing. I also bought small, I think they are called RC bearings. I think they are used for remote controlled vehicles, like remote controlled cars and this kind of stuff. Very, very tiny bearings. You might also find them in some of the trackball designs. I think there was even one on Reddit just recently. Let's go my keyboards. I think someone was posting. Oh yeah, this one. Yeah, so I think he used the same bearings that I am talking about right now. Yeah, over these ones. I think they are like 6 millimeters, and the shaft is 2, and the thickness is 3. I think it's like 632 or something like that. I used to use them as well, but honestly they kind of suck, and I moved away from them. Yeah, but the build is very nice, especially the glow. Beautiful. Really nice board. Really cool. And I was supposed to ask where did he find those white balls. They look kind of like ping pong balls. But I haven't seen any other color than blue, gray, like all the colors that you can find on Logitech trackballs. I think these are the most common. Maybe if you're lucky you can find a red one, like if you go AliExpress. And trackball ball replacement, like this. Oh, they have different colors now even. Oh wow, this is something new. Yeah, so as you can see, you can have either red one, you can have, these are new ones. They're not too great actually. Yeah, they used to sell color like this, like dark gray. And here they show it's like dark gray, but when you get it's like actually blue. Well, actually I have it on my newest build. It's okay, but I was a little bit disappointed because when I received it, one of the balls was scratched. So obviously when I was rotating it, the scratch was you could feel it on the ball. So yeah. Or maybe he bought these like ceramic balls, but they don't really have this size. So no, most probably not. Yeah, but these are kind of cool. Quite cheap actually, $12. I wonder if it's any good. Okay, someone says the quality is good. Maybe I should give it a try. Oh, they have even bigger ones, 55 millimeters. Another fan of these. Yeah, nice colors actually. Okay, anyway, the original balls, if you wanted to buy, you can either get like this, or this type of color, or just like or this color, this one. I think it's the original blue. Also, although it doesn't really look like the original blue. Yeah, anyways, not important. Let's get back to the cat. But what I wanted to do, I wanted to try if we can fit this horizontal design, if it can fit in a standard key size, which is 1905 by 1905. So let's make a key outline maybe. I am too far, can't see. Key outline, okay. So we can make a line over here. And let's make this line 1905. Oh, okay, so maybe we can, let's make a rectangle over here. Let's start from here and let's make it 1905 by 1905. Okay, so we don't really have that much space as I would have hoped for. So this kind of sucks. How far is it from here to here? Okay, we don't know. Maybe like this, if I do, okay. So it's 12 millimeters. Okay, that is not great. So we won't have that much space if you want to accommodate two encoders. Okay, let's mock up this bearing. 3 that's 6 by 3 by 2, I think. Let's do the so first we have the shaft, which is 2 millimeters, I think. Then the whole thing is 6, and I think the thickness is 3. Okay, so if we look at it right now, okay, let's align this with our imaginary shaft over here. Okay, this surface needs to stay for a while. Okay, so what is the distance between here and here? We have only 9 millimeters, not even 9. We have 8.5 over here. So let's say we want to have a knob. Let's make it over here. Okay, not maybe here. Let's make it here so we can hook up to the center. So this is the bottom. So definitely let's make, I don't know. I can already tell that it's not gonna be good. Okay, come on, shift from here. Okay, 17.2. Let's make it 17, for example. Okay, looks like even 5mm encoder won't really help us much. We still won't be able to fit in one key. And also we need a... Let's make something like a holder for it. So I think I should go with a plane. I would just move it to here. Oh, we have our print done already. If you can see. I will just go and pick it up soon. Okay, something that would hold the bearing. Now let's assume ideal it will be like this. So the bearing is let's make it like 5 maybe 4. Okay, 4 this way and 4mm this way, and let's just cut the bearing and let's move it like maybe to the half of the bearing size. Yeah, so Yeah, let's say we have something that will hold the bearing like that. So my idea of having two encoders is it's a pipe dream. Yeah, so the knob will be too small. Definitely will be hitting this part when we rotate. So let's pull it, let's make it like 6 millimeters. Oh, come on. So this will be our, let's say, our bottom plate for Chordie. I think it's 6 millimeters. Okay, it's 7. Is it 7? Really? Okay. But this is with the bottom plate. So but the plate itself is less. It's 4.2 actually. Okay, so make it 4.2. Okay, let's say that we could go bigger. Let's say that we can go all the way to the, okay. So if we do like 25 millimeters, okay, 25 looks much better. But then we will just have to route everything outside of this. So we can't really have any wires going like through this part like we used to, because the wheel will be kind of like sticking inside. Okay, so idea is maybe not that stupid yet. Something definitely to check out. Also, there is another thing what we can do actually. I will just show it maybe over here. How deep is this? Well, I was thinking maybe I could just embed the encoder into this wall, like so. So it would be like sitting inside, but there isn't that much space over here, sadly. The thickness is just 2.5. So it's roughly half the thickness of the encoder. That's like 4.1, more or less. Okay, not quite happy with it. Okay, I will just go and fetch the print. I will be right back. Okay, so here we are. I wonder what is broken with this one. Which part won't fit? So far it looks okay. Can't go automatic here, have to use this one. Okay, seems that Mi Box, you were right. Looks like one screw is enough. Okay, even the shaft fits okay. You can see like the holes align. And so this is how the new shaft looks like. So this is the thick part, and this is the thin part that goes inside the encoder. So this is way more like stiff. I don't think it's that easy to break. The other one I broke two in one stream. So yeah, that's not that bad actually. Okay, so we have that. So now I guess I would just go with the top piece, like so. Where's my favorite screwdriver? There it is. There you go. Automation. If only those screws were made out of steel, so the magnet can hold it. Are we okay with just one screw? Yeah, I think it locked over here. It doesn't move. That's great. If we can save time, it's always a gain for us. Yeah, so you can see I was trying to lift the bearing with a screwdriver, and I bent it. So that's why I came up with this idea. Okay, now the question is, okay, looks like it went through. Okay, so the height is not that bad if you look at it this way. Yeah, seems okay. Well, this key is lower than this one, so it doesn't really bother us that much. Okay. Well, I don't have the bottom. I have to attach the bottom. Yeah, right. I don't have the bottom part for this yet. Let's take a look. Because okay, let's do a test like this without any fit. So let's take a look. Like, does it really move? Yeah. Right. It doesn't really. I definitely need the bottom. It's kind of hard. I think it was easier over here. Yeah, but the bearing is rather soft. I mean, it's spinning okay. It doesn't seem to be any friction. Let's take one more look. Okay. And now I won't be able to take it out. I need a magnet. I'll be right back. Okay, it's not that great. I was expecting more. Let's see if we have any bottom plate. Okay, we have this part. There's one more. Okay, this one should do. Seems like I didn't have the centerpiece with the feet. Okay, anyways, okay, I think I need shorter screws. I already removed them. I'll be right back. No, I have it here. Okay. I hope this will be enough. That didn't go well. Okay. I don't think I had the bottom piece assembled. And that one doesn't even fit. Well, maybe there was no centerpiece at all. Okay, so this is chalk, so without the sponge, a little bit high. Okay. Well, it's not great, sadly. Well, I was expecting that it will be a little bit better. Maybe it's too small. Well, it's better than the other one, but still not as soft as I would want it to be. I'm under impression that if it was a little bit bigger, if it was like 32 millimeters, maybe the force will be like more evenly distributed around, and maybe it would be easier to rotate. Oh, that is a little bit underwhelming. Yeah, so just the bearing is super soft. If I could have that, would be great. Like no force needed. I think even without the bottom feet, I don't think it will be moving the keyboard. It's just perfect. Having such scroll would be so great. I guess we have to wait for those magnetic MT6071. Oh, sorry, I messed up the name. Yeah, but just the bearing without the shaft that goes into the encoder. Yeah, that is super soft. Yeah, that would be perfect. Okay, so what we need to do next? I think we need to redesign this and make it a bit bigger, because this one is a quick look, 24. So if we can make it like 32 and check if it makes any difference, if the knob is a bit bigger, should make a difference actually. Yeah, and other than that, we still haven't finished our horizontal one. But the horizontal one doesn't look too promising actually. Oh, this is not even in the center. Okay, this is the center already. Yeah, so with the bigger knob, with the knob of 25, I will be still a little bit big. Like it would need more space. It's a pity I don't have these to test. Yeah, so having two is definitely not an option. And what is the distance? What's the height of this? It's 2.4. So we can cut like maybe 1.2 millimeter, and that's not that much. Hmm. Hard to tell if it's gonna fit or not. Okay, let's go back to Chordie. So I wanted to check if we can make it like 32. I think we had some other encoders 32 over here. The horizontal ones, where is it? Yeah, over here. Yeah, so we had a 32 millimeter knob right here. Okay, so how to quickly swap it without putting too much work? What was the size of this knob again? 25? 25? 24.5 actually. So let's make it knob 32, and I will just copy the necessary stuff. So we need this, and we need this part. Okay, also will be needing this, and together with that, and also the harness for the encoder. We can make it one piece. I didn't make it one piece. Okay, now we have one piece. Okay, that's fine. So let's make 32 millimeters, and let's make it construction. Okay, and now let's move it around. I need a line, so then I can make a, let's make it like this, construction, and one more construction line here. So this will help me to align it, because I can't do it from the circle. So now I can have a point over here, so I can do from here, let's make it 1.2. And the same from here, 1.2. Okay, so let's make this wall all the way to here. This scroll is very annoying. So we have this, we need to make it shorter. Because now we have to move the whole thing to align with this. Okay, so we have the hole, like so. Okay, what I'm gonna do, I need the shaft as well. Okay, I think the shaft is somewhere else. It's over here. So let's do it like this. I'm just gonna yank it from here. Not sure what happened. Why did it copy instead of moving? So just align it like this, and so now we have to make it bigger. So it's 32 by 2. Okay, now it's huge. So we have to make some extra space for the screws. Okay, let's move it to here. The stupid scroll. I don't understand, like, when I have item selected, why does it like go so wonky? Okay, so is this enough? Should be enough. Or maybe I should just move it a little bit. Make it 0.7. Such a good number. Okay, so one screw is done. But technically we don't need another one, from what I can remember. But we just need to extend this okay, this looks clean enough, I would say. Okay, let's enable the knob. Okay, so looks like we are good. It does have some clearance. Maybe let's extend this wall a little bit by 2 millimeters, okay. I was thinking if making like a pattern around, would it change anything? Would it make it easier to like aim your finger in it? Like, you know, we can try actually. Hopefully it won't be difficult. Let's see. Can we make a pattern like this? And if we... Okay, yes, we can. Okay, how many do we want? Let's say 6. Let's say 100%. Okay, this looks better. Oh, not quite actually. Okay, is it better right now? Okay, let's just move it a little bit outwards, like so. Okay, not so bad, not so bad. Can we fit more? Oh, we can do like 45. Okay, this looks like it's enough. Okay, so we have this part redesigned, actually. Should I make a bottom for it as well? I think I will skip, because it looks like there is still enough space. If you look at it, even if you extend a little, it shouldn't be sticking out too much, like over here. So maybe it won't make the whole keyboard wobble. Okay, chat, are we printing and waiting? Or should I just test it off stream? Plenty of time. Okay, we can print it. One try. If something is messed up, that's it. I'm not fixing it on stream. Okay, so let's make it knob shaft 32. Okay, this will be our top. Where is the bottom? Oh, there it is. Okay, let's print it. So it's gonna be knob 32 bottom. Okay, back to Bamboo. Let's make a new project. Okay, so this one, and our new and fancy knob. Okay, so we have to flip it around like so. Let's arrange. Okay. I don't like in bamboo that you rotate with left, and when you have like a cursor over something, and then you want to rotate, you will just move it. Like, and you can't change this. I would rather have something else to rotate. Especially that the middle mouse and the right mouse does the same. They both move left and right. So why not have the like the right one to rotate, middle one to pan left and right, and this one the left one just to select items. Kind of stupid. It would be okay if you could change it, but you can't. Yet another app with stupid design. There were way too many like this recently. So what is the printer doing? I think I left the bed clean. Yeah, good that you have plenty of time. I wish I had it too. Okay, so let it print for a while. Well, in the meantime, I can disassemble what we have here. I said it's easy to remove. Maybe not so much. Okay, we can leave the bottom because it's not really attached to this part. Only this screw is holding it. So that is great, actually. Less work. Where is the Allen key? Over here. Okay. Maybe not less work, but now I have to do manual. Okay, so we have this out. And let's try to get the bearing out. Well, I can use the screwdriver because now it won't damage it because it goes very easily. Yeah, like so. Just need to slide it underneath and then you can, yeah. And so as you can see, it kind of like bends inside. Okay, how is the print? Hasn't started yet even. Okay, so we have this done. Did we put all the parts? Ah, yes. So we have bottom, top, and the knob. All right. What else can we do? Looking at our encoders over here. So this one is 25. Well, actually, this might even work. I can't wait for the encoders to arrive so we can test live. How does it fit? Okay, I'm back. Makes me wonder if, for example, a design like this would be feasible. So let's say we have the bottom over here, and if we can have the encoder at an angle like this, maybe. I wonder how it would be with the scrolling. So like if the encoder was like this, so the knob would be also something like that, like at that angle. Like if you make it like round, would it be okay? Or something worth checking maybe? I don't think it will rotate that well. Like, let's take a look before I break something. Let's take the longer one, 16. Okay, so let's say it would be like this at an angle. Oh, actually, not that bad. Interesting, actually, if it was at an angle. Let's take one more look at all the balls for the trackballs. I think they dropped in price a little. Maybe that's the one, the white ones that the guy just showed. Oh no, they don't really have a 34. Well, you can always design for a different one if you buy 40 millimeters or 50. That's kind of interesting. I wonder how it would work with this zirconium bearing balls, the one that I'm using, the small ones. I think I'm using 3 millimeter ones. They don't show this over here. I think I'm using this for my drag balls as a bearing ball. Oh wow, even more colors. That is cool. About the price also, 27, kind of expensive. And not good reviews, I wonder what's wrong. Okay, not an original one. Oh well. Maybe he posted what kind of balls he's using. Okay, doesn't really say what balls he's using. Oh, it looks cool. I like the colors and everything. And these look like PTFE. I think it might be 40 maybe, or maybe 30. Yeah, very cool. Yeah, we'll be doing RGB as well sometime later. Not for Chordie, because Chordie doesn't really have a... There is no way to connect 5 wires. I mean, we can always go with the USB-C to connect the halves, but the problem is that for Chordie, the halves sometimes tend to be quite close, and the USB wires that you can buy, they don't really allow for such a close. They are too stiff, so only TRRS cable makes sense here. So I think we're gonna... Or we can always make just one color if you really want to have RGB lighting. Then we can just use just one color. Yeah, well, very cool build. Very nice. Okay, how is our print going? 18 minutes. That's quite some time. So basically, looking at it, the size of the encoder, if you want to go horizontal, it doesn't really make a difference, because it seems like we need a larger knob anyway. And if you want to do it vertical, like this, then we can't really have a big one. It looks like 25 is the max that we can get. And actually we do have 25 somewhere. Was this? I think this one is bigger. Oh, this one's 25. Oh, so it's actually quite huge. So it's gonna be the same size as this one. It doesn't really look well. Well, yeah, basically, if you look at it, there's not that much difference in size. They are still quite large. Yeah, it's almost the same size, yeah. Well, we can always go without the top, just have the top exposed like this. Yeah, so it's a little bit better now. And maybe we can even go with a smaller. So this one is 8.5, so it's gonna be 17 millimeters. Yeah, something definitely that needs more exploring, but only when I get the original, I mean only when I get the parts. Okay, I think I'm gonna cut the stream short. There's still plenty of time before it prints, and there's not much really I can do right now with the design. So I will definitely brief you on the next stream how it went. Most probably it's broken and doesn't fit at all, so you're not gonna lose much. Yeah, I will see you on Friday then. We can continue. Maybe some parts will arrive by then. That would be super cool. So we'll have more things to do. Okay, but for today, thank you very much for watching, for interacting on the chat. I hope this episode was educational. We didn't break this many things as usual. I think this is a record episode because we... Thanks, bye-bye. Yeah, thank you as well. See you on Friday. Okay, anyways, thank you for watching, and I think I will see you on Friday. Goodbye, take care.